All right, commands. So fortunately, you see how many slides there are. In order to use the command line, you do have to go through a good number of commands before things start getting useful. So ls is a list. This is kind of like dir inside of command line, or I'm sorry, in the command prompt. So if I go up here and I'm going to do a clear to clear my screen, ls, notice that I'm inside this directory, which is where I checked out the course repository. And it reflects what's in GitHub, which I have a directory called cheat sheets, course materials, and lab ones are all directory. On my terminal, directories are colored light blue, or that bluish color. They may be different on your machine depending on what you use. I just realized that might be really hard to see from the back row. Is it? No? Great. And then a regular file is that lime green. I prefer lime green, just the way I am. If you do an ls-l, it's going to give you a long listing, which gives you more information, namely permissions, which we will get to in a moment. We're going to skip that number for now. This is the user, and this is the group. We'll get to that as well. This is the size in bytes, and this is the day that it was created or last updated. Notice that this file is only 20 bytes. That can be a little hard to see, especially when the file is huge. So if you add an H, which stands for human readable, 4K, 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 and then 20 bytes. That way, if it's a long thing, it'll say 2.3 gigs. Oh, okay. A little easier to see. Now, if you do ls-lah, I can keep adding commands inside right after that dash. The A stands for show everything. That includes the hidden files. Right now there's dot and dot dot. I'll get to that in a moment, but I just want to show you that dot A, when you do a regular ls, it does not show you every single file, but a dot A will show you all the files. All right, did I get everything? Yeah, that's enough. CD is how you change your directory. By the way, in Linux, you use the word directory. In Windows, you use the word folder. They're the same thing. I'm going to use the word directory because that's better. So you can CD to change into a different directory. Hey, look, I just realized I forgot to show you that .git exists. That's where Git stores all of its information about the repository. So if I CD into cheat sheets, oh, and very important, I'm going to do this a lot. I go CD, and then I want to type in the directory I want to change into. I do ch, and then instead of having to type out the rest, I'm going to hit tab, and it's going to fill in the rest of it based on what is available. This is incredibly helpful. Don't forget about tab completion. It'll make your life way, way, way better. And then I hit enter. Notice that my directory has changed. I can do another ls, and now I have two PDFs. Inside the Linux world, I like to use events in order to open up a PDF. So I run events, the program, and then the PDF I want to open. And this is the command line, which is a bunch of different useful things, handling files, listing files, file name, etc., etc. And then inside events, I do Control W to quit. How are we doing so far? When I did LAH, notice that dot existed. What that is actually a pointer to your parent directory. So if I go cd dot, notice that I'm now back up a directory to cheat sheets. Out of cheat sheets and inside the GitHub directory. So if I do cd dot, anyone want to take a guess what that does?
Take you back to the base directory.
Oh, good guess. It takes you. What's it?
Goes back one.
It takes you to the directory you're currently in. I know that seems dumb, but that's what it does. 2 goes back, 1 is where you are. Seems a little weird, but there's times when you need to have a pointer back to the current directory. So it's, yeah, just how it is. But there's no triple or anything. All right, make dir and remove dir. So let me see, we're in here. Let me make a directory called class code. Notice when I did an ls, these were the files available. By the way, if I say these are the files available, a directory is a file in Linux. So when I say files, that includes directory. So these are the files available, which include directories. make dir class code, hit enter. Hey, notice when it succeeds, it doesn't tell you anything. Linux, basically the way it works, if everything's good, it doesn't tell you. If there's a problem, then it will shout at you. Do an ls, hey look, class code's available now. So let's cd into class code, do an ls, there's nothing in there. So we're going to do make dir, let's do CLI practice. And I'll cd into that. The reason for that is we're going to do a lot of other class code when we get the chance. All right. Oh, we can remove a directory. All right, sure. mkdir delete me. rmdir delete me. And then I do an ls and it's gone. All right, I did that a little quick. Was everyone watching? Great. All right, you can create a file with cat. I'm actually going to skip this because you should just use nano or vi. Well, all right, I'll show you cat. You don't have to do it this way. But you do cat and then this greater than sign file.txt, and you can go hello, enter Control D, and then if I vi the file, hey look, it's in there. Bless you again. We'll get to all that in a moment. We can copy files. In Windows, you had to type out copy, but that has way too many letters, so we just do cp, copy file into file, we'll call it file2.txt. Do an ls, ls-l, there they are. They're both 7 bytes. So now we have 2 files. All right, this hopefully is not crazy yet. Recursive copy. You want to copy everything over? Ooh, excuse me. So if I do cd, I don't see why it needs CL practice 2. Now if I do an ls on practice, hey look, when you do ls, you can actually tell it what you want to do a listing on. So I'm going to do a listing of the CLI practice directory, those files, and then I can do practice 2, and it's those files, and it's the same set of files. Why? When you do -r, it's called recursively, which means it takes what you have and goes down and does the command for everything inside of it as well. So it did it for the directory, then it did for each file. So if your directory had thousands of other directories in it, it would copy each one of them over as well. All right, remove. Here we go. So you can try and remove CL practice 2, but it'll say you can't because it's a directory. But I can go into CL practice 2, and I can remove file 2, then do an ls, and it's gone. I can go back up and I can do rm-recursively on CL practice 2. Notice that beforehand I couldn't remove it because it was a directory, but if I recursively delete it, then I delete it and everything inside of it. And now that one's gone. All right. I know, guys, it's a little long. F, forces, which means it tries to tell the OS to do it anyways. Recursive to do everything. O-V will actually display everything you removed as well. By the way, very important about remove. Notice it just deleted it. It didn't ask you if you wanted it deleted. It did not move it to a recycling bin. It just deleted it. Keep that in mind. The tool is not going to be not going to help you if you accidentally delete something on accident. There's none of that in here. Just got to be careful. You'll get used to it. Just how it is. All right, any of the commands except a files parameter will work with the current directory. All right. So I kind of jumped around. You're starting to get an idea of what this is because of the directory. If you want to know your full direct path, you do pwd. And so I'm currently in home quest CSU courses CSCI 315 fall 2019 class code. So that's the full path to my directory. For those of you who aren't used to the Linux world, there's no C drive, D drive, or anything. Everything just begins at /. And if you want to mount more than one hard drive, it would be under different things inside of /. Excuse me. So right now I have a home directory inside of /. I think I only have one hard drive. Yeah, I only have one hard drive, so it's all mount on that one hard drive. Home, quest, etc., etc. Yep. Let's see. Use relative or absolute paths. Do I go into what the difference is? Nope. All right, well, I'll show you. So if I want to do an ls on the class practice, this is using a relative path because it doesn't start with a slash. What that means is when you do the ls, it's going to concatenate what you have afterwards with what your current directory is. So it does ls on CLI practice. And you'll see that I got that. I could have done this. What's that going to display? The same thing. The point is the two commands do the same thing in the end because the relative path pastes what your current directory is. And then the second one is absolute because it starts with slash and then goes down to it. Y'all see the difference? Great. All right, you can move a file. Go back. Go file 2.txt to file 3.txt. Hey, what does that actually do? Kind of. No, I moved it. It's called something else I've learned in Windows. Rename. There is no rename in Linux. You just move the file. When you move the file, you're actually changing its name. Is all you're doing because you're changing where it's located. So you're changing what directory it's in and what it's called. That's called moving it. So moving and renaming in Linux are the same thing. So if I wanted to take this file and move it up a level, I could do file 3 ... Where is that going to place it?
It's going to place it in the directory 1 back.
1 back, which is the class code directory. So I move it, ls, it's no longer there. I do an ls and slash, looks like it's there. Yep, there it is. So if I want to move it back to where it needed to go, to where it was originally, what would I do?
You put the slash and then the folder name you want to go move it to?
So the first command is what you're moving, and the second command is where it's going. So what's the first command? So I started with mv space, now I need to
File 3.txt, then slash the folder you want to move it to.
right, or I could use the relative addressing and do it this way. I just didn't want to type everything out. You're not wrong, I just didn't want to type it out. And then you do an else practice, there it is. All right, how we're doing? Beautiful. File, oh yeah. Linux does actually have a pretty good file command. And it'll tell you what a file is. So it's like, oh, this is definitely an ASCII text file. In Linux, the extension to files is completely meaningless. It does not mean a thing. I could have taken, and just to help you understand that, I just removed it. I can still edit it right there. And if I do a file on it, still says it's ASCII text. The extension doesn't mean a thing. All right, Windows it does, Linux doesn't care. That's just there to help when you're looking at it, give you a clue as to what the file is. All right, so let's do a couple more commands. So let's go into CLI practice, long file. So we're going to go, oops, perfect. Hey, oh yeah, you didn't know how to do that. Yep, goodbye. All right, then I'm just going to save it. How big is that file? Ooh, 6K, great. All right, so if I call head on long file, it prints out the first 10 lines. I can do also head -n 20 to print out the first 20 lines of that file. Everyone with me so far? What do you think tail does? No, there we go. There it is. And it takes the same commands. Doing great. Ah, word count. So you can always do a word count on a long file. And I keep forgetting what these are. I think it's first one is lines, second one is number of words, third one is number of characters. There we go. All right. All right, lastly, find will help you find a file on your machine. I'm not going to go through these two. Grep will help you search for a specific text and display it. This is going to end up being very helpful when you're programming. I could give you an example now, but I don't think it would stick very much, so we'll do that one later. And then linking is if you want to have two files do the same thing, essentially. I don't think we're going to need that, so we won't do that one either. All right. Any questions on those commands? I know these three I just talked about, but everything else, are we good so far? All right. This is a pretty important picture. Inside of, well, it's actually pretty important for multiple reasons. So we'll first talk about why it's important in the Linux world and then the computer science world. So you have a program. It's called, when you run your program, it becomes a process. The reason why you got to keep this distinct is you could have multiple processes that are running the same program. So if you have multiple instances of your program running, they're running as separate processes. So a process is your program running, or an instance of your program running. Standard in comes to your keyboard. Oh, did standard in, standard out? Great. Standard out goes to your monitor as well as standard error as well. But these, I don't know if you knew this, but they're two completely different streams when they come out, which means you can capture them separately. All right. The other reason why this is important is we have a box with arrows. And you'll find out quickly that in computer science, we love our boxes and arrows. And you have a box and some arrows, and you have one arrow that goes in and at least another arrow that goes out. What is one thing you can definitely do?
Write a test case.
I'm sorry?
Write a test case.
We could write a test. Oh yeah, I like that. Functional, yeah, with a little diagram, flow diagram, and write some test cases going in and coming out. Excellent observation, yes. What's another thing we could do? So I told you can run more than one process, right? Right. So if you had two processes, what could you do with the two processes? We could put them together. So we take the out of one and make it the input of the other. And you can chain these up all you want. Hey, wait a minute. What data structure does this look like? Okay, linked list, yeah. But I haven't talked about linked list in this class yet. So a queue, right. Hey, it's a queue. Hey, it's already a queue. All right. This can keep going on and on. You can keep chaining up your programs. And the reason this really has to deal with, or really deals with the core of why Linux is a very strong environment, is each command, notice that each command did one very minor, small, simple thing. The Linux philosophy is whenever you write a program, have it do one thing, have it do it really well, and be able to interface with everyone else. The reason for that is so you can just chain together everything you want. And if all of a sudden someone else comes up with a better way to do what you did, they just take your stuff out and drop in the new stuff and continue on. That's the philosophy that goes on here. But right here we have an ls that's then piped to more. So here's an example from the command line. So when you use that, more is a program, and ls is a program we already talked about. So we're going to do an ls on everything along inside of etc. etc usually contains all your configuration files. And then we're going to pipe it, aka take the standard out of it, and have the standard into more. And more is simply a way to display more information on the screen than your screen can show. So ls-al on etc, pipe that to more. Hey, look at all that stuff. and I'm going to hit the space bar, and that's how I keep going down for the different items that I have. All right, how are we doing? You can redirect different things. So, for example, up here, if I did ls on al on etsy, and I redirect it to out, so the standard out got redirected to a file called out, I can vim out, and there's all the contents inside of it, and I can look through it and do what I want to with it. That's probably going to be pretty helpful at some point, especially if the errors. Now, I told you that standard out and standard error and standard out are different. For example, if I do 2 out, notice it still printed it to the screen. The reason for that is 2 is standard error, and ls didn't have any errors, so it didn't display any errors, and therefore it printed standard out to the screen. So if you had an error, you can dump it to a file by putting that 2 greater than there, like that. All right. So more, we already showed that with this, and you could spacebar it. What do you think less does? Think head and tail. So I'll take it, instead of having more, I'll have less. Looks similarly, but notice with more I can only go down a page. With less I can arrow down and then arrow back up. So less is more. It's more than more. Less is more.
Why would they do it like that?
Because less is more. I mean, if you want to get rid of a process that's running, you run the kill command. Your program that you're running, the shell is called bash. These people don't end. You should wait. You should see the what was it? The tool chain to try and keep all the tools out. They start talking about witches and hosts and all these other different demonic things, trying to get rid of all your demons. And it's called demons when it's a program that's running in the background. It does not end. But I can tell you're all tired now. If you don't start laughing at these terrible, terrible puns, this class is going to be really, really long. Okay, guys? All right, cat. Concatenate. So I used cat for a while, but I haven't talked about it. Cat will concatenate the file to standard out. So if I cat file, we'll do long file, it cats all of that out. Well, if cat concatenates it to the file, what do you think tac does? Say it? What?
The opposite of concatenate, I don't know what that is.
Yes. Well, no, you got it. Well, concatenate puts it out in order, so tac is going to put it out in reverse order. Get it? There we go. At least one person's catching on. I'll take a groan. You can do.
So obvious. That's so dumb.
I'll take groans. You can groan. It's fine. It's fine. All right, printing. Y'all aren't going to print here, but there are print commands: LP, LP stat, and cancel. LPR. So there's some more. We're not going to use that. Use password without the OR because that's just way too much typing to change the password for your user. You type man. Ooh, this gets can get bad sometimes. Man stands for manual pages, not a man. So you can do man ls. So for example, man ls, and it'll give you a little thing. It says ls. What's called ls? List the directories. It has options in a file. Here's all the all commands, and you can use the arrows to move down. There are man pages for basically all the commands you have out there. If you think the man pages are too hard to read, you can use info as well and do info ls. Also, most commands have a -- help. So if I do ls -- help, it does not help you. We'll do a grep dash dash help. There we go. Where's page up? Page up. So there's my grep dash dash help. There's my grep options, and it gives you everything as well. So there's different ways to get help on a command. All right, let's take another moment.